Okay, in the last video we had spent some time with the binomial expansion series, and we're including several videos now that are related to this theme, along with our permutations and combinations and probability problems, because it's going to be useful for developing the background for handling generating functions, ordinary generating functions, as well as exponential generating functions, and in turn we can use those as very powerful tools for solving more complicated permutation and combination problems that right now we can't handle because we simply don't have the mathematical tools to do it with. So that's why we're spending a little bit of time here with the binomial expansion theorem. And for this video, as in the previous video and in the next two videos, we're going to be thinking about the binomial expansion theorem when it is raised to a positive exponent. And then what we're going to do is take a look at the Taylor expansion series, and that in turn will show us how we can use the binomial expansion theorem in situations where the exponent is a negative number. But again, for this particular video, we just want to use the binomial expansion theorem again to handle a more basic type problem. So suppose we had, say, this kind of a situation where there is 2 divided by x plus 3 times the square root of x raised to the 4th power. And we want to go ahead and use our binomial expansion theorem to get an expression for this. So like we did in the previous video, we say, okay, this term here, that's our a term. The b term, that corresponds to 3 times the square root of x, and n, our exponent, is 4. So let's just go ahead and plug this into the formula like we did in the previous video and see what comes out. So we have this. N is 4. We start off with k being equal to 0, so that gives us this binomial coefficient. The a term, which is this, is going to be raised to the n minus 0 power, or 4 minus 0, which is 4. So the next term now is going to be 4. K now equals 1. So this term now is going to be the 4 minus 1 power, or that's cubed. And now our b term, which is this, will be to the 1st power. In here, our b term, since k was 0, was to the 0 power, which is just 1. That's how we don't bother writing it in. Okay, let's continue. That's our next term. Now, the power on this, that exponent is going to decrease by 1 more time, by 1 once again. So that gives us squared. Because now k is 2, so 4 minus 2 is 2. K is now 2, so now this is 3 times the square root of x squared. That takes care of that term, plus 4 over 3. This binomial coefficient. Now we're going to have 4 minus 3 is 1, so this is just 2 over x to the 1st power. This term, k is now 3, so that's cubed. Try to keep these in focus as we proceed along here, plus the last term, 4 over 4. N is 4, minus 4 is 0, so that's 2 over x to the 0 power, that's 1. And then this term is going to be k now equals n, which is 4. And there it is. So you can see it's a pretty handy tool. All we have to do now is evaluate our binomial coefficients, and hopefully from the work that we've done in the previous videos, you can handle these pretty efficiently by now. By the way, if you just found us on YouTube, if you can go to the website at digital-university.org, you will find all of our permutation and combination videos are all listed there in their proper sequence. And in fact, at the website there's hundreds of more problem-solving videos with calculus, vector analysis, differential equations, and so forth. But okay, let's continue on with our problem here. This binomial coefficient, of course, is just 1. So we have 2 over x plus 3 times the square root of x to the 4th power equals, that's 1, 16 over x to the 4th. And this is going to be 4 factorial over 1 factorial times 3 factorial. So that's just 4. So we have 4 times 2 cubed is 8 times 3. Okay, so here we have 32 times 3 is 96. That's our coefficient. And what do we have here? X to the 1/2 divided by x to the 3/2. So that's x to the minus 5/2. And then here, for this binomial coefficient, 4 over 2, that's 6. So from here we have 6 times 4. 3 squared is 9. So you have 24 times 9. I think that's 216. And what else do we have? Here we have the square root of x squared, that's x. X divided by x squared, that's going to be 1 over x. So we have 216 divided by x. That's this term. Okay, what else do we have? 2 more terms to go through. 4 over 3, this binomial coefficient, again, that is just 4. So for here we have 4 times 2. 3 cubed is 27. So for this term we have 8 times 27. Again, that is 216. Then here we have x to the 3/2 divided by x. That's x to the 1/2, or that's the square root of x. So that takes care of that term. Now we have this one. That's just 1. 3 to the 4th power is 3 squared times 3 squared. That's 81. And the square root of x to the 4th power, that's x squared. So there it is. Again, we just wanted to provide another straightforward example of using the binomial coefficient, or the binomial expansion theorem. And as you can see, it's a pretty handy device. What we'll do in the next video is solve one more basic problem using the binomial expansion theorem. Then we'll talk a little bit about Pascal's triangle, and then in the video after that, we want to take a more close look at the binomial expansion theorem when this is a positive number, and we're not going to prove this equation, but we'll try and give an intuitive justification as to why it does take this particular form. So come back and join us for those videos, and we'll try and solve some more problems. And then, like I say, once we get some of this groundwork laid out, then we'll get to exponential generating functions and ordinary generating functions, and then we'll use those as very powerful tools to solve some of the more complicated combination and permutation problems. So come back, join us for those videos, and again, just to remind you, if you can get to the website at digital-university.org, all the videos are presented for you there in their proper sequence.